Couple of things. Come on, guys. There's a few things we want to discuss before I give you guys some problems here. One of the things that we haven't really discussed a lot about in this chapter so far is really been any of the modeling. And what happens when we start doing the trigonometry modeling, there's many different things that'll come about. Trig modeling happens all the time in physics. And a lot of times when you're talking about physics stuff, you're going to be given some mathematical model. What I mean by the model is that you'll be given the equation that works, and it's going to be up to you to decipher the information that goes into the equation from some problem. For example, we've got one here called projectile distance. And projectile distance, if you look at this, how many different variables are there? There's three of them. There's three of them. You've got distance, velocity, and theta, your angle. So what will happen here is you're going to be given two of those three. More often than not, you'll probably be given velocity and theta or distance and theta. When you're multiplying the two into that, it usually isn't the unknown for this class. You'll see the unknown double angle when you're in pre-calc.
So we'll never have to figure out the theta from this?
You may or may not. Usually, what I'm saying, usually the theta is given when you're working with these. So obviously, if you have to solve for the velocity, what would you have to do at the very end?
Square root.
Yeah, got a square root because it's got a square to it. Distance is very easy. It's just a straight substitution style problem. Now, a real easy example of what something like this would look like is a kicking a soccer ball problem. So Kayla, this is right up your alley.
Oh, thanks.
You're welcome.
Oh, she takes.
There, she's a soccer player.
Oh,
I was. What's that? You did?
No.
Oh, that's embarrassing.
That's why I'm like,
Anyway, what'll happen is you're going to get this model. I forgot to bring this along. You'll get this model within a problem. And I was telling the other classes is that obviously on the test you'll have some sort of a modeling problem. Whether it's this specific model or some other mathematical model with trig function, the model itself will be provided. Which means you don't have to worry about memorizing formulas or deriving any formulas or anything like that. It'll be within the context of the problem. It'll just be up to you to know how to use them. Okay. So if this one here, if you're playing soccer, Kayla and I, we're kicking the ball around because we're having a good old time. And we both can kick the ball at 42 feet per second because, you know, we have the instrumentation to measure all that. And not only that, we carry the compass and the protractors around to measure the angles at which we kick things, because that's what you do. And I kick the ball at 45 degrees, and she kicks the ball at 60. I think that's. What is that? Bad? Well, it's because your legs are short. I don't know. I played soccer for all about 4 minutes of my life.
You have to lift it up under your foot and then just lift your foot up.
Anyway, so what happens is, how much better of a soccer player am I than Caleb?
Really? A lot. At least 8 times.
So here's what happens. We're trying to find the distance for mine. Take 42 squared over 32, sine of 2 times 45, and then Kayla's 42 squared over 32, sine of 2 times 60. One thing to caution you guys when you have that double in front of the your theta, just do that in your head as you're entering it in the calculator. What's 2 times 45?
90.
What's 2 times 60? Put that right into the calculator. Depending upon how you write it up, if you're not careful with your parentheses and how this sets itself out, it's very easy to get the wrong angle for theta. Okay? So it's very easy to double one of these angles in your head. So I can just do a quick little alpha y equals, create my fraction, 42 squared over 32 times the sine of 90, and I get 55.125, we'll call that feet. It's not very far.
That sucks.
Yeah, like I said, that's why I swam. Do that again with the alpha y equals 42 squared over 32 sine of 120. And Kayla can only kick the ball 47.74 feet. So how much better at soccer am I than she is? What would I have to do? Oh, you're thinking about percent better? Okay, I like that. That's a good way to look at it. How about distance-wise? How much further did I kick the ball first?
7.39 feet.
All right. So in the grand scheme of things, am I really that much better than she is?
Yes.
Also, she could kick it at a different angle.
She could. She would probably be a lot better at it than I
How
would.
much better you are, it's just the fact that you're better.
Thank you. It was well spoken. But Kayla, you probably are tremendously better than I am because, like I said, I played soccer for about 4 minutes. No, I'm sure she's. I have no doubt. No, I'm serious. Why?
Let's go to the soccer field.
I'm already conceding that she's going to win.
I'll get over that she's going to win and then play her.
I'm sorry, I have to lose.
Oh, who are you talking to?
The other question that people tend to forget is, how do I write out the 6 trig functions given that information? If I want to write out the 6 trig functions given that information, what do I know about this information? Good. So think about its cosine and sine, but now think about it also in terms of x's and y's. That's x and y. What are we missing? R.
So what do we?
How do I find R? What we're doing here, Hunter, is cosine x over r, sine y over r, tangent y over x, secant r over x, cosecant.
Is this like 1, 0, 1?
Something along those lines, but in this case here, they're not on the quadrantal, so we don't have to worry about it. This is actually an ordered pair in space. And when we have this ordered pair in space, what quadrant are we sitting in? We're sitting in the 4th quadrant. So that means my x value is 1, my y value is -√3, which means theta is placed there. Theta is always, always, always placed back at the origin. Remember that? When we're placing these things on the grid? So now when you're walking around to set up your x's and your y's and your r's, we have to first of all solve for r. So what's 1 squared?
1.
What's -3 or -√3 squared?
3.
What's 1 plus 3?
4.
What's this word? 4.
2.
Good. Yes, sir.
Sorry, I forgot how you determine the direction, I should say, of the triangle. 'Cause I know in some things like the theta being like an -3 kind of.
Yeah. What happens here is if you plot that point in space, you went over 1, you went down √3, and the point was placed here. This is the terminal side of theta. So as this one comes around, there's 1, and this is that -√3, which means theta is placed there. Theta always works back to the origin. Your point out in space, if it was out here, goes down and over, theta would be here.
But I mean, like, sometimes the side of the transom.
Hypotenuse?
Yeah. That was like, it was placed kind of 90 degree was like close to the other.
Yes, yes, I know what you're talking about. That's when you're on the quadrantal. That's a little bit different. That, when you're doing the 6, you can do that as well with the same thing. And we've done that problem. I'll do one real quick here after this one. I know exactly what you're talking about. Okay? So here it's just a matter of just substituting in and writing out your inverses. The trickiest part here, guys, is when you have to rationalize your denominators. Just be careful with it. Okay? What Leaf is getting at is, how do I write out my 6 trig functions here? That's what you're talking about. If I want to write out my 6 trig functions at 0, -1, what's your r value? 1. So then you just use, whenever you're on your quadrantal, this is still your x and your y. If you're on a quadrangle, your R value is always going to be 1. Because it's going to be 0 squared plus negative 1 squared, or it's going to be 0 squared plus 1 squared. So your R value will always equal 1. And when you write them out, sine is x over r, cosine y over r, tangent, y over x, and then your inverses. In this case here, my sine value is 0, because that is the ordered pair. Cosine is negative 1. Tangent would be negative 1 divided by 0. Oh, did I write that?
Yeah.
I wrote, sorry, I just realized I wrote cosine for the wrong one. Sorry, cosine was x over r. Sorry about that. So sine, that's correct, that's correct. Tangent would be negative 1 over 0. Can I have 0 in my denominator? So what's tangent at that value?
Undefined.
It's undefined. So now when I do my inverses, the inverse function of cosine is what? It's secant, yeah. What's the inverse of 0? Undefined. The inverse of sine is cosecant. The inverse of negative 1 is negative 1. And then the inverse of tangent is the cotangent. Inverse of undefined is 0. Okay. Is that what you're talking about? So those aren't that bad. You just have to remember where you're being placed, which one goes with what. Anytime you're on a quadrangle, remember that r is 1. The other questions that have come up so far today was, oh boy, how do I work with area of sectors and arc length? It's been a while since we've done this. Remember, arc length. Arc length was given to you in terms of S, was your radius times theta. And what was theta always in?
Radians.
Radians. Theta was always in radians. If it was not in radians, if it was given to you in degrees, how do you convert degrees into radians again? Good. Multiply by pi and divide by 180. So obviously this first one's very simple. It's already in terms of radians. So in this case, if I wanted to figure out what the arc length would be, it's 5 pi over 2. If I go to the one that does not have that, here I'm going to get 12 times 25 pi over 180. And now this should be something I would be able to simplify without a calculator. Uh-oh. Think about this, guys. 12 and 180, what can you simplify out?
6.
Do 6. Just do 6s right away. If I do 6, I get I get a 2 and a 30.
Which can become 115, right?
Okay, you go 1 and 15. And now 15 and 25, what can you take out? 5s. If I drop out 5s, I get a 5 and a 3, so my answer is 5 pi over 3. You're working those reference angles, okay? Again, if it happens to be on a part of the test that does not allow the calculator, that's the type of simplification that you should be able to do. If it is on a part with the calculator, can I type that into my calculator and hit math, enter, enter? What can I not have in my calculator if I'm doing that? No, I can do degrees with this stuff, but what can't I put in my calculator to do the math, enter, enter? You can't put pi in your calculator and do math, enter, enter. It's not like, remember, I don't know if any of you guys had a TI-30, those the multi-views last year? The little gray ones that always simplify the radicals. If those calculators would keep pi along for the ride, these don't. So if you do have a part on the test where it does allow you to keep your answers, where you have a calculator and you have to give it in radians and you have to keep pi in there, just do everything that you would normally, math, enter, enter, slap a pi in the numerator, you're gonna be fine. Okay? Yes?
We bring our calculation last year, just like a bunch of calculations.
Load it up.
Have
like
4
that,
different
yeah.
calculators for different things.
Never know what you're gonna need, right? The other part of this one was doing the area of the sector. The area of the sector was a little bit different. Area of the sector was 1/2 the radius squared times theta. Again, theta was in degrees. Some people have been doing this a little bit differently. What they've been doing, writing it out as r squared times theta over 2. Some people have found that it's a little bit cleaner to do it that way. It doesn't matter, whichever one you want to do. I think the other example was r was 16 and theta is 210. And I want to find the area of the sector that has that information. Again, when I just write it out, substituting my values. 1/2 of 16 squared times 210 pi over 180. What's 16 squared?
Wait, oh, it's one,
That has to be
wait, only
Yeah,
the two?
whenever you're dealing with areas of sector or areas, or arc length, you're always going to go into radians. Yes, sir?
Only the 210 is divided by 180?
Well, the whole thing can be. I'm just writing it up like that.
Because you can simplify it and basically go.
What's 16 squared? What's half of it? Come on.
128.
All right, so I'm at 128, 210, or 21, 18, and a pi. What can you divide 21 and 18 by? 3. 128 and 6, what can you divide those out by? It is a 6. Would you feel better if I fixed it?
Yes.
6 and 128, what can I simplify? 2s. Is there anything else? What's 64 times 7? Bet you it ends in an 8.
448.
What's wrong with that? How do you do that?
It was so easy.
Oh, it's so easy. Just start to keep dividing up by common, or at least common factor.
64 times 7.
If they're even, divide by 2. If they're even, divided by 3, divided by
Times
3.
9 and 8, so 4 times 7.
Yeah, it's really it's really one way of doing it. I saw the 21 and the 18 and I knew I can do 3 right. You understand why I cut out the zeros, right?
No, we were at 7 or 3.
So where'd the 3 go?
The 3 is still there.
Oh.
The 3 stayed. The 3 is there forever. It will always be there.
What are they both missing? Why if I cut out the zeros?
I'm hearing Richie yelling over here. I just want to say it. I don't want to please him, so I'm not going to say it. I'm not going to say it.
Have you never really?
Vaguely?
You really think
Alright. The other stuff that came out,
Give me that right now.
if you're, I'm just pulling this up here real quick. This is all in the chapter review. Basically, the stuff that's going to be on the test, 13.1, 2, 3, and 4. Law of sines, law of cosines won't be on there. 13.1, 2, 3, and 4 will be. 13.1 had all your basic right triangle trick stuff that you guys have all done in the past. Okay? That stuff is all still there. Yeah? 1 through 4. Okay? Yes, sir.
What is the non-calculator portion of?
The non-calculator portion.
Sorry.
The non-calculator portion will mirror the ideas of what you guys did on the that little 4-question quiz. Yeah, once Brittany takes it.
Brittany.
Brittany! Brittany Patroll.
You ruined that.
It should only take you a couple minutes.
Great.
If you're caught up, you should be able to take it right now. The non-calculator stuff will mirror those 4 questions, as well as what we did 2 days ago. And you guys flew through these. Remember when you did the inverse trig functions? Non-calculator? That would be what it was, okay? The inverse trig function with non-calculator, trig function non-calculator. Maybe converting back and forth radians to degrees non-calculators, that shouldn't be so bad. I guess I can just get rid of the other ones. It's not that big a deal. Oh, yeah. different versions of everything I do for you guys. You guys all talk too much. If you look at the first one, you've got the cosecant of negative 15 pi over 3. Which means when I see that, the first thing I'm going to do is try to simplify how many times does 3 go into 15? 5. It's negative, so it's a negative 5. So what I'm doing here is I'm going to plot it. 1, 2, 3, 4, 5. So my ordered pair there is negative 1 and 0.
Wait, it was negative ones.
Yeah.
I just know. Can you explain why it's negative one? Why is it? Why is it this thing?
When you're on the quadrantal, your ordered pairs are always 1 and 0. They just flip-flop themselves around. Because remember, the radius of these circles is always going to be 1.
Oh, okay.
And it has to, as it goes around, it's just changing from 1, 0, 0, 1, negative 1, and so on. Okay? So when I'm at this value here, the sign value, the sign here is 0. The inverse of 0 then would be undefined. Okay? Yes, sir?
I was going to ask why negative, or why R is always positive.
When you use the quadrant, not quadrant, when you use the Pythagorean theorem, you're squaring the x and the y, it always becomes positive.
So like,
R will always be
so
positive.
because like in this case it's equal to or the
Whenever you're on, yeah, but remember, when you're using, if I use this as x and y, the r value is the square root of x squared and y squared. What's negative 1 squared? 1. 1 and 0 is 1, square root of that is 1.
So R is always
R is always
like
negative.
easy enough.
Whoever's on that.
When it's on the axis, like this, yeah. Okay. 4 was the other one, I think?
Yeah.
Was it 4? Okay. When you're on 4 there, you have cotangent of 990. So I had to figure out how many times around I'm going. If I back out 360, was it 3.5, I think? Because,
You get to 270.
yeah, so let's see. It's here then, right?
Yeah, that's fine.
So you wind up there, the ordered pair at that value is at 0, negative 1. Now, cotangent is the inverse of tangent. If tangent is y over x, cotangent is x over y. So in this case here, it's going to be 0 over negative 1, which is 0. Does that make more sense? You have to remember how many times you got to unwind it, find your reference angle here.
I figured it out right, but then I didn't realize that they were like questions. I didn't guess.
Oh,
That's
yeah,
where
I
figured
didn't
it
know
out.
around that.
Don't do that. Okay. Other questions on that? Let me give you guys the little sheet that I made for you. There's 2 word problems I want you to take a look at real quick using that projectile stuff. On page, which one is this? On page 789, I'll leave these up right away so you can try these out. Page 789, I want you to do 69 and 70, please. There are 2 projectile problems that uses that same formula that we just did, just so you guys get the idea of how it works in a word problem. It's not that difficult. If you don't have your book, I'll leave it